Number 14, I went ahead and wrote down the quadratic formula because I can't remember it, and I knew I was going to need it for this problem. What is the solution to this quadratic equation? The first thing you want to check is that it is set equal to 0. If that were not a 0 right there, you would need to solve it for set it equal to 0. But it is a 0. So we're going to go ahead and work from there. And I'm going to take this 14 out because I need to use the space. I'm going to need a lot of space. So in this particular quadratic equation, we need to identify our values for A, B, and C. A is a 5, B is a -2, and C is a +5. And then we're ready to substitute in the formula. So X is -2 plus or minus the square root of -2 to the second power minus 4 times 5 times 5. And all of that mess is over 2 times 5. So I'm going to jump down here and go ahead and draw my fraction bar. And then just to help us stay organized, I'm going to highlight my terms. So here's a -2. That makes a +2. Okay. Then plus or minus the square root of, you get a different color. We have a -2 times -2. That's going to give me a +4 under the radical. Minus, oh boy, this is where our imaginary numbers are going to be introduced. 4 times 5 times 5, that's 4 times 25, or 100. So all I'm doing is simplifying. And then on the bottom, I have 2 times 5, that is 10. I'll go ahead and highlight that for you, so you can see where I'm getting all this. So we're a little bit simpler. It's getting simpler with each step, but I need to come on down and keep working. That bottom is as simple as it gets. The 2 plus minus. The square root of 4 is 2, so I can go ahead and simplify that a little bit more. The square root of 4 is 2. Actually, I don't want to do that. Excuse me. I just had a lapse there. 4 minus 100 is -96. I'm sorry, I was getting ahead of myself. We have to do the subtraction before we can square root. So this is a little bit ugly. I can tell you one thing with certainty. That negative sign right there is going to create an imaginary number here in just a minute. So a negative sign under a radical is going to give you an imaginary number. But let's see what we come up with. Would you agree with me that a 96 can be made using multiplying with a 6? Is that what I want to do? Yes. Times a 16. That is 96. 16 is a perfect square. So I can take the square root of 16. My pencil's dying, so let me just drop it on there 1 second and let it charge so I don't, oh, it's 20%. We're okay. So I can take the square root of 16. That's a perfect square. I don't want to lose that negative sign either. That's important. So here's what it's going to simplify to. X equals 2 plus or minus. What is the square root of 16? It's 4. And I need to bring the imaginary number in there to take care of that negative sign. So we end up with 4i. And the square root of 6 has to stay under there because I haven't done anything with that yet. And then don't forget your 10 on the bottom. And you're almost there. I'm going to factor a 2 out of everything. In other words, I'm going to divide all of my numbers by 2, except the square root of 6. That one's protected under there. We're going to leave him alone because he's protected by the radical. 2 into 2 is 1. 2 into 4 is 2. And 2 into 10 is 5. And this is the final answer, finally. We have x equals 1 plus or minus 2 imaginary, because we had the negative under there, square root of 6 over 5. And that's the answer you're looking for. And it's A as in alpha. This is one of those problems I would just guess on. If you just don't want to do it, make a guess and keep on going.